Can you tell me? You have
Okay, sir.
problem. Okay, wait.
Sir, electrochemistry.
Okay, electrochemistry. So I'm gonna revise this electrochemistry for you. Okay.
Okay, sir.
Just wait a minute.
Sir, chemical kinetics.
Okay. And then is there any other?
Sir, I'll let you know more, but
Okay, okay.
that's about it for now.
Okay, wait a minute. Mhm. Okay, so I'm going to write the topic here. First of all, we are going to start this chemical kinetics first. It is small and it's easy, very easy. So in revision, you are going to solve all the NCERT problem, okay, and as well as the what we say, as well as uh, the assignment that you have got. Okay,
Yes,
so
sir.
first of all, rate. First, we talk about rate. Rate is basically change in concentration. If concentration is given, then we deal in concentration, and if pressure is given, then we deal in pressure. A rate is equal to change in concentration or pressure of either reactant or product divided by time. And from here, we can get the value of the unit of rate. If you're going to deal in concentration, that means molarity. And the unit of molarity is mole per liter and time as a unit second. So the unit of rate is mole per liter per second. Or you can say if you are going to deal in pressure, so it will be atm per second or bar per second, whatever you have taken the unit of bar. So this is your rate. After this, there is a term, this is your basically reactant and product. So we write basically rate is equal to plus minus delta C, that stand for both reactant or product upon delta T, time taken to change. Now, important point is that if you are going to do it for reactant, there will be negative sign. There will be negative sign upon delta T. Why this negative sign? This negative sign tells you that it is decreasing. It is decreasing. That's why we use negative sign, because reactant decreases, and for product we use positive because it increases. Wait a minute. Because it increases. So there is another term that is basically your rate of formation and rate of disappearance. So a rate of either we use rate of disappearance, and you know what does disappearance mean? So this term used for, we use it for reactant, and that is equal to basically negative delta R upon delta T. And for product, we often use appearance or or formation, and that is equal to basically plus delta P, change in concentration of product, upon delta T. Is that clear? So
Yes, sir.
if a reaction is given like AA plus BB, that will give you CC plus DD. And if you are going to calculate the rate of appearance or disappearance, first we are going to deal with disappearance. Whenever there is a term disappearance, so there should be a click in your mind that this disappearance we use for reactants. So we are going to specify here that rate of disappearance of first A. So what you are going to do, just write negative and change in concentration of A upon delta T. Then another reactant is also there, rate of disappearance of B, and then put a negative sign since it is a reactant and change in concentration of B upon delta T. Is that clear? Now we are going to use this
Yes,
for
sir.
product, and you know that rate of for product we use either appearance or formation. There are two products, so I'm going to specify it of C, that means positive change in concentration of delta C upon delta T. Then again, rate of appearance of D, then it will be plus delta D upon delta T. Is that clear? So this is how we deal with
Yes, sir.
the rate. Okay. Now the next is basically the rate in terms of a stoichiometric coefficient, rate of a chemical reaction, rate of a chemical reaction. We are not talking about appearance and disappearance, but rate of a chemical reaction in terms of stoichiometric, in terms of stoichiometric. Now, as you can see, so if you are going to write the rate of reaction in terms of a stoichiometric coefficient of a reaction, that I am going to write AA plus BB, that will give you CC plus DD. So how you are going to write? First, it is similar. For reactant, we write negative. But in terms of coefficient, whatever is the coefficient, that will come in denominator. And then delta A upon delta T. And in this rate of reaction, that are they these are all are equal. Then it will be equal to this is also reactant negative. It's a stoichiometric coefficient like this, and then change in concentration of B upon delta T. That will be equal to, since it is product, so plus 1 by C, change in concentration of C upon delta T. That will be equal to plus 1 by D, change in concentration of D upon delta T. Is that clear?
Yes, sir.
Now, have you seen that this part that I'm going to talk about, this part is basically, what is this? 1 by A into this part is what? Rate of disappearance. Rate of disappearance of A. That will be equal to this part. You can see this part is basically what? 1 by B, rate of disappearance of B. Yes or no?
Yes, sir.
Then this part 1 by C into a rate of appearance or formation of C. And then this will be equal to 1 by D, a rate of appearance or formation of D. So it's very easy. There will be some question regarding this. The rate of reaction will be given, or either the rate of appearance or disappearance will be given. So by using this, we can equate them and easily solve them. Are you getting my point? These all are equal to each other.
Yes, sir.
So if you will know, if you know the value of one, you can easily calculate the value of rate of appearance or disappearance of each and every component in this reaction. Is that clear?
Yes, sir.
Okay, so just wait. I'm gonna share. Is there any? Mm, no, there is no shit. Mm, not a problem. I'm going to share the assignment, and you can easily practice right now. So it will be very beneficial for you. Are you able to see the screen? No, right?
No, sir.
Just wait a minute. You'll be able to see it. So I think you can do it without wasting time, or you can easily do this. And you also have done this previously, so you will not take that much time, right?
Yes, sir.
Okay. Oh, please do it. Let me know. Are you able to see this thing?
Yes, sir.
Because I'm searching another assignment. Are you done with this?
Doing, sir.
Okay.
Sir, I've sent the answers.
Wait a minute, Nafisa. Yes, so Nafisa, first of all, come to the first question. Did you solve the first question? You didn't solve the first question correctly. Nafisa, am I audible?
Yes, sir, I forgot how to do.
See, this is how you are going to make a difference. You need to practice a lot. This is the reaction that is given, and In an experiment, rate of formation of NO is given. Rate of formation of NO is given, and we need to calculate rate of disappearance of ammonia and rate of formation of water. So you did this, you have written the rate of reaction, that is correct. And it is also given that rate of formation. So if you are going to write rate of formation of NO, that will be equal to basically what? 3.6, and from this reaction you know that it will be plus delta NO upon delta T. Yes or no? This will be the rate of formation,
Yes, sir.
which has a value that is basically 3.6 into 10 raised to the power minus 3, right?
Yes,
Yes
sir.
or no? Now see, you have written the rate of reaction, that is minus 1 by 4 delta, or D you can use NH3 upon delta T. That will be equal to basically it's that will be equal to minus 1 by 5. You haven't written, and it is not required to write. And then plus delta 1 by sorry, plus 1 by 4 delta NO upon delta T, right? And here it will be written as
Yes, sir.
plus 1 by 6 delta H2 upon delta T, delta H2 upon delta T. Now see, what is this? If you will look only at this part, this is your rate of disappearance. This negative with negative, this is the rate of disappearance of NH3. Yes or no? Yes or no?
Yes, sir.
So I'm going to write 1 by 4, and this part that I just rounded is basically rate of disappearance of NH3. Disappearance of NH3. And all these are equal. You can see this is equal to this, and this is equal to this, and this is given. Basically, is equal to, I'm going to write 1 by 4, and this is your what? This is your rate of formation of NO, which is given as 3.6. So 1 by 4 into 3.6 into 10 raised to the power minus 3. Can I write this? Yes or no? If you are not getting it,
Yes,
just
sir.
let me know. I will share my OneNote. Are you able to understand it clearly? Yes or no?
Yes, sir.
Okay, then these are equal. That means basically what you need to do. 1 by 4 will be cancelled. So rate of disappearance of NH3 will be this much. 3.6 into 10 raised to the power minus 3. Are you getting my point?
Yes, sir.
It is also given that we need to calculate rate of formation of water. So this is your rate of formation of water, and it will be equal to this much. That means 1 by 4 into delta NO upon delta T has a value that is 3.6 into 10 raised to the power minus 3. That will be equal to 1 by 6 into this is what? Rate of formation of H2O. So you can see 2 2 is 4, 2 3 is 6. This 3 will multiply in this, so it becomes 7.2 into 10 raised to the power minus 3. Are you getting my point?
Yes, sir.
Very good. The next one that you have solved is correct, and this is also correct. Only this type of questions you need to keep it in mind. Okay, it's very important. Are you getting my
Yes,
point?
sir. Yes, sir.
Very good. Very good. Wait a minute. Here you are. There you are. Here you are. Okay. Okay, Nafisa. So let me know. Are you able to see this scene?
Yes, sir.
Very good. And please do practice. If you will not do practice, you have opportunities, so grab it before the time.
Okay, sir.
And okay, wait a minute, just let me see that. Okay. Okay, okay, okay. Okay, so you have seen that the uh, uh, what we say, rate law expression. Rate law expression. You know that rate law expression is in terms of reactant, not product. In terms of reactant. It's also very important to note that if you have a reaction that is going into A is converting into B, so you just need to keep on the focus on your reactants. Either it is 1, 2, 3, 4, whatever it is. Just take it as this AA plus BB that is going to give you CC and DD. So you don't need to deal with this product. Rate law expression is in terms of reactant, and you can see the rate is directly proportional to the reactant, product of the reactant raised to the power something, and this power is experimentally determined, and to remove this proportionality sign we are going to use a rate constant, that is this, and this k is basically your rate constant which only depends on temperature. This is your rate constant which only depends on temperature, and this x and y, if you are going to sum this or add this power of a rate law expression, then you will be getting n, that is order of reaction. Are you getting my point?
Yes, sir.
If a rate law expression is given like this, r is equal to k into a raised to the power half into b raised to the power half. So if you need to calculate the order which is denoted by n, what you need to do, just add the power, you will get the order of reaction. This order of reaction n can be negative, can be positive, can be zero, can be fraction, anything. Are you getting my point?
Yes, sir.
Now, the next point is, if I'll give you rate law expression, rate is equal to, that is, R is equal to K into A into B square C Q. My first question is, calculate the order of reaction. Calculate the order of reaction. Just let me know the answer so that I will ask the next question. Let me know when you are done with this. Have you got the answer of the order of reaction from this rate law expression? Yes or no? Nafisa? Nafisa, are you there? You are not audible. Can you
No, sir.
still?
I didn't get.
Oh, oh. What is the is this rate law expression? Yes or no?
Yes.
What is the power of a? Are
Zero,
you
one,
zero, zero or one? You are
one.
confused. Are you sure about this? Is it one?
Yes, sir.
One. What is the power of b?
Two,
What is the power of c?
three,
So what is the total sum of this?
six.
So it is sixth order. It's so easy. What I did in the last question. What is the order of the reaction? What I did here? I added the power. If you are going to add the power, you will get order of reaction. Half plus half
Yes, sir.
that. Yes, sir. Okay. You forgot everything, right? You didn't
Yes,
do
sir.
it. Hmm, okay. So can you tell me the order of reaction? Hmm.
Sir, it would be zero. It would cancel out.
Zero order. Zero order. That's good. 1 by 2 plus minus half that will be equal to 1 by 2 minus 1 by 2. That will be zero order reaction. Okay. Is that clear?
Yes, sir. Yes, sir.
Now come to this point. If a rate law expression is given like this, A into B whole square. First of all, let me know the order of reaction. What will be the order of reaction now?
Sir, three,
Third order. Very good.
third
Now,
order.
now it is given that how the rate, how the rate will affect when A is concentration of A is doubled. Concentration of A is double. Can you solve this? I have given you this question in your class. How this rate R will affect if you are going to increase the concentration of A to double. Can you do this? Yes or no?
Yes, sir.
Okay, please do it. If you're not able to do it, just let me know. Will you be able to solve it? Yes or no? Just let me know if you are having any issue.
No, sir.
Okay, no problem. Not a problem. See, this is the rate of reaction that is given. Now the original rate of reaction R dash will be K. K will be as it is. What you did according to the question, concentration of A is double, right? B is as it
Yes,
is.
sir.
Are you getting my point? So if you're
Yes,
going
sir.
to solve it, 2, I'm going to take it out and it will be like this, right?
Yes, sir.
So this is your equation number 2. This is your equation number 1. I'm going to divide this. And you can see this is your R upon R dash. R is basically equal to K into A into B whole square. And R dash is equal to 2K into A into B whole square. So what you are going to do? You are going to cancel this. So if you are going to solve it, R upon R dash, that will be equal to 1 by 2. So R dash, the new rate will be double of the previous old.
Okay, sir.
Can I change the slide?
Yes, sir.
Okay. So see, this is the second question I'm going to ask you. If concentration, this is finished. Now, this is your rate of reaction. Now, if the concentration of B is double, then what would be the how the rate will affect? Let me know if you are unable to solve it. Okay.
Sir, it would be 1/4 because B is to the power of 2.
1 by 4, that means what does this means?
Four
Mm,
times it will increase
4 times.
4R.
So that means basically the new rate will be 4 times the old rate, right?
Yes, sir.
So you did correctly. Now, concentration of A and B both is doubled. Both is doubled. Now tell me.
Sir, it would be 6 or
6 or 8?
6.
No, no. So this is your old rate of reaction. The new rate of reaction will be K into, it is going to do double of A and double of B, right?
Yes, sir. Yeah,
So there is
yes.
a square. So 2 to the 4 it will be, and here it is 2.
Yes.
So 2 into 4 it will be 8 into
Oh, okay,
8K.
okay. Multiplied. Okay, sir, yeah.
So if you are going to divide it, R upon R dash, R is equal to basically K into A into B square upon 8K A B square. Are you getting my point?
Yes, sir,
So
okay.
this will be cancelled. Okay.
Yes, sir,
So can you
understood.
tell me, do you remember the formula for what we say? Mm, Formula of first order and second order reaction, like integrated rate equation. Do you remember integrated
No, sir.
rate equation for zero order first, for zero order reaction? So if you're going for zero order reaction, K will be equal to initial concentration minus final concentration divided by delta T. Do you remember now? Delta T or T,
Yes, sir.
basically T it is. So this is the formula for zero order. For first order, if you're going to look at it, so it will be K
K
into
is equivalent to
2.303
2.303 by T
log
log R, not by R.
of very good. So this is the formula, right?
Yes, sir.
Now, if we're going to look at the, I'm going to share another screen which is based upon this. Okay, so you can do the rest question easily, especially these questions can be easily done by you.
Sir, can you scroll down?
Is it enough or should I scroll?
Sir, can you scroll? Oh yeah, okay. First order is in order. First order is first order. Sir, I've sent it to you.
Okay. Very good. Yes, send it to me. The expression of the it will be very good, and very good. Uh, this is the first order. Hmm.
Okay, sir.
Wait a minute, please. Okay, you have written it correctly. Very good. Now do solve this. By applying the integrated rate equation according to their order of reaction, you can solve the fifth
Okay,
one
sir.
first, fifth one or sixth one both. Are you done with this?
No, sir.
Mm. Have you completed?
Uh, no, sir. I'm doing calculation, but this is what I got so far.
No, wait a minute.
Sir, I've sent it to you.
What you just said?
Sir, I've
Wait a
sent
minute.
it to
Question
you.
number
Like,
five. Yeah, yeah, yeah.
I did
Wait a
half.
minute. Okay. First order reaction used today 0.303 divided by time is 200 seconds. And then log of. You did this part, fifth, right? I'm solving this part, sorry. So K will
Yes,
be equal to 2.303 and time is what? Not that much. The rate constant is given. We need to calculate the time, right? So T will be equal to 2.303 and rate constant is 15 into 10
yes,
raised to
sir.
the power minus 3 log of initial concentration is 5 and final concentration is 3, right? So you just need to solve this part. Okay, so it will be log 5 minus log 3.
Yes, sir.
And then you will be getting it. After solving it, you will be getting 34.07 seconds. Is that clear?
Oh, okay, sir.
In this, you can see this is the initial concentration and this is your final concentration. So you are going to put it here and you can solve it. So log 8 will be
Okay.
can be written as log 2 raised to the power